All right, hello and welcome to the Torpedo system. Now, this is probably the project I'm most excited about just because no team has done it yet, and most of our team leads were against it at the beginning, but we were able to convince them, and we just got confirmation from RoboSub themselves that self-guided torpedoes are allowed. Funnily enough, University of Alberta is trying to do the same thing for this year, or for next year's competition. So everyone's getting onto this plane. We want to be the first, we want to do the best, right? So here's the deal. We had designed a torpedo system last year, but we didn't actually implement it. It was spring-loaded launcher mechanism. Um, but we never actually got around to testing that. And honestly, we're gonna scrap that, everything we did for last year, and we're gonna start fresh. Um, so let me just start by throwing a few ideas at you guys. Actually, no. Let me give you a general overview first of all what we're doing. So basically what we want to have is a plastic hull that is waterproof with integrated electronics. We'll go over what those look like later. A propeller, which then powers this torpedo, and then fins that can control its roll, pitch, and yaw, as well as its heading. Now, as you can imagine, um, that's a lot to fit in a small form factor. So by RoboSub, we have the rule that it needs to be smaller than 2 inches by 2 inches by. I need to double check the length, but I think it was something around 10 inches. So quite small. Also they cannot travel faster to the point where a diver can't hold on to them and physically stop them, or catch them. And then we need to shroud the propeller as well. So those are just some general rules we need to keep in mind. Also, it needs to be lighter than 2 pounds, which shouldn't be an issue, but just something to keep in the back of our heads. Now, in terms of electronics, I want it to be powered by a brushless DC motor because we can run those. Uh, yeah, brushless motor, BLDC motor. Because we can run those underwater. And here's just one example I found on Amazon real quick, and these are tiny, right? These come as really small form factors. And they are intrinsically waterproof. So with that. This one might actually be too small, but this one runs on 1S power. Also very important. We don't want to go up to 2S because then we actually need to fit a 2S battery um into the hull of the torpedo. And that's I don't want to put that much power into something that will probably leak and set the battery on fire. And also the S rating refers to how many cells are in series. So for our main submarine, we're using 2S cells, but two of them in series. So overall, we have 4S batteries. Um, for the torpedo themselves, I want to stick to 1S, which means just one lithium ion cell or lithium polymer cell, which will then range from 3.3 volts to 4.2 volts. Um, or as an alternative, what we could also do is use supercapacitors, which would then allow us to A, use a higher voltage, and B, um, for the duration of the submarine, of the torpedo that it's actually moving for, we'd have to test how long it would be in the water for. But I think supercapacitors would have enough stored energy to actually have us drive that distance. So that's the first thing we want to research is, are we going to go with supercapacitors or are we going to go with lithium ion cells? If we do end up going with supercapacitors, that obviously also simplifies because we don't need any battery management system. We don't need a battery charging system. We don't need undervolt protection system. And it's a lot safer if water goes into the submarine. So I would tend to like to go with supercapacitors. But again, that's something we will need to research and ideally do that for Thursday if we're going with supercapacitors or with lithium ion cells. Now, that covers the propulsion system. I possibly one more thing to keep in mind is may need two motors to have them counter rotating so that if we only have one motor and it rotates, that would rotate or induce a torque on the entire, oh God, on the entire torpedo, which can be counteracted with the fins we add. But I think it might be simpler if we actually have two motors. Judging by the size of them, we could probably fit two next to each other. Again, that's something we may need to research just in terms of power draw. Is that realistic? Um, and these motors come in all sorts of shapes and sizes. So also probably something we can look into is what kV rating, which means how many thousand RPMs per volt do these spin at. So these spin quite fast, these small motors. As we are underwater, that might cause an issue because we need them to spin rather slowly. But then again, we'd have to design a propeller that actually works with the speed, whatever the motor is turning at. Specifications are here. There's a lot of drone sites where you can find these tiny motors. Feel free, or please do research into different sizes and come up with a comparison that allows us to decide what to go with and what is our best option, how much power it will draw, how efficient it is, et cetera, et cetera. Then, for the other electronics, obviously, if we are running brushless DC motors, we will need ESCs. I found a few tiny ones on here, 4 amps, that should be plenty. But again, 1S rated. ESCs is basically what tells the motor how fast to spin, and it converts our DC signal. So we add 5 volts, 3.3 to 4.2 volts plus minus signal that tells it how fast to spin. And then these 3 wires go to the motor. And that basically then allows us to control the motors, control how fast they spin, control how they react. In terms of embedded systems, we are going to be running probably a Arduino Nano. If you have any other ideas, I literally just took this because it's what I know. Feel free to let me know. I'm open to any ideas. I want to be as small as possible in the form factor. We need at least 5 PWM outputs, if not 6 if we're running 2 motors, which means 4 for the 4 fins and 1 or 2 for the motors. We need an IMU that actually tells us the orientation of the torpedo, how it's lifting, how it's moving, right? If it's spinning. And that would then allow us to counteract any of those motions. And that's something our embedded system then would have to control. Then we will need servos to control these fins. I'm most worried about these because of their size. Ideally they'd be waterproof, but we need to find a way to actually control those fins without letting water into the torpedo, but also fitting for these servos to control 4 different fins. So this is going to be probably our biggest challenge. I want someone dedicated to figuring out how we're going to use these, what size of these, how small we can get them. Yeah, and then I just threw some bearings there to see if we could find a size that would match these. I couldn't find a size yet, but perhaps we can find a size of bearings that would then waterproof from the outside. Again, first time we're doing this project, so not much experience here. Feel free to do as much research as you can on these different components I just highlighted. There was one more. Oh, right. So our plan for the torpedo in general right now, I forgot to say this earlier, is to have it just correct for its altitude or its pitch, yaw, and roll, right? And then basically just be able to go in a perfectly straight line. Later, we want to try integrating some sort of communication protocol between the main submarine and the torpedo, which would perhaps work over lasers or ultrasonic sound, although that might be hard to pick up on in the torpedo, but we'll get to that bridge when we cross it. Or we want to be able to actually have a camera in the front of the torpedo that then uses some sort of color recognition algorithm or even object detection algorithm, which I might be again hard to implement in this form factor. But yeah, for this terms project and probably what we're going to run with in the competition this year is really just a torpedo that can stabilize its altitude, yaw, and pitch, or yaw, pitch, roll. And also correct those, right? To make sure it's going straight. Then in terms of launching the torpedo, there was a few ideas of using using a magnetic launch system. I don't think we need to do that because we do have a propeller on the thing. So what we might be able to do is use a Hall effect sensor inside the torpedo and an electromagnet inside the hull. And then if the electromagnet switches off, the Hall effect sensor is like, oh, no more magnetic field. I'm going to turn on my motor until the supercapacitors or whatever stops it from doing so, right? So turn off the electromagnet. Hall effect sensor says no more magnetic field. Torpedo starts driving itself out of the hull. Um, I think that's pretty much it for the torpedoes. In terms of project, I know you guys are around 5 people right now, so I want each of you to take one of these parts and just do some research on it for the design review. I will be your point of contact for the torpedo, so I'll make sure that everything works together smoothly and we get this project done. That is just for now until we start ordering parts, and then I want one of you guys to take the lead on the torpedoes. Um, but just discuss in the Discord right now what you want to do, what parts you want to research, how you're going to approach it. And then ideally for the design review on Thursday, we'd have a general outline of what we're doing with the torpedoes, what parts we're using, answering those questions I asked earlier. Um, yeah, that's pretty much it. Thank you guys.